Good afternoon, everybody. Did I unmute?
Afternoon, sir.
Afternoon.
Okay, good.
Afternoon, sir.
All right.
Afternoon.
Good afternoon. All right. Sorry for the late start, but for some reason I just had some problems with the login. I don't know what happened, but my Zoom account wouldn't let me in, and then it sort of messed up the settings and all of that. So we're good to go now, though. All right. So we're on the topic of bearings, and we're at the stage now where we basically just need to practice some questions to, sort of put everything together. So the idea is to practice some questions today, tomorrow, and Saturday to see how well we can cement this topic. All right. Hope everybody attend all the days. So hope everybody's attending today. Everybody will attend tomorrow and on Saturday. All right, so that is the plan. And I'll make announcements if we have to make any changes. I know it's the season, and so a lot of things happening. And so I might have to make a few changes and stuff. So I'm happy that I'm able to have this session this evening, though. If it is even for 1 hour, just to do a couple of questions and let us see how we put this all together. It's a very nice and easy topic. All right, so I'm on the May 2023 paper. This paper here, May 2023, the last exam that was set by CXC. We are at number 10, no, number 9, which is in section 2. And it's a geometry and trigonometry section. And here we have a bearings question right here. All right, and what you'll find is that generally speaking, these questions are basically the same. As I look at this triangle, I see 3 sides and I don't see any angle. So I know it's not a right angle triangle, so I cannot use Pythagoras' theorem on it. I cannot use SOHCAHTOA. And so if I want to find any of these 3 angles right now, I would have to use a cosine rule, because to use a sine rule, you must have one angle that you know on a side opposite to it. We don't have that. We don't have any angle based on it. But let's read the information. It says the diagram below shows a triangular field LMP on horizontal ground. All right, so this is clearly the north direction. All right, it says calculate the value of angle MLP. That's the angle of L right here. M to L to P, this angle. All right, so as I said, we have to use cosine rule. Once you know only 3 sides and no angle, you must use cosine rule. I'm just going to call it, for now, let's call it phi. Or can I call it angle L now? Since this is L, we can just call it angle L. All right, let's call it phi and put it on the diagram, just for reference. All right, let me change the color of this. I'm going to call this angle here phi, and I'm going to use a cosine rule. Now, remember, the cosine, you have to be careful now. Cosine rule really is set up around having 2 sides, which is this side, and the angle between them. So you're doing the cosine rule now, is like your focus, it's almost like you know those 2 sides and you're trying to find this side over here. So you start like that. But what it is that you actually know this side over here and you're trying to find the angle. So you have to transpose to find the angle. All right, so this is like our 2 sides and an angle between. So this will be the side opposite the angle. So that's what you normally start with. So using cosine rule, guys. All right, so cosine rule. So let's write it here, cosine rule. And I tell you all the time in the class that you don't get a lot of space to do this work. You see the small amount of space that is given. So you're not really expected to use too many lines to solve this thing. That's why we have to practice and cut out the unnecessary steps by practicing. So using the cosine rule. And the cosine rule, I said, will start out like Pythagoras' theorem. So this would be like your hypotenuse if this was a 90 degree. So it is 180 squared would be equal to this side squared plus this side squared, which is 150 squared, plus the 120 squared. But this is not actual an hypotenuse. It should be a square. This is not an hypotenuse. And so you have to subtract a piece. So you're subtracting 2 times the product of the 150 and the 120, product of the two sides, 150 and the 120. And then multiply that by the cosine of the angle between these two sides. The angle between them is the phi there. So I'm going to put phi. I remember we're trying to find phi. So now we need to transpose and make this a subject. All right. Note you don't have a lot of space to do this thing. I can look at it and write what the cos theta will be equal to, you know. What it is that you're going to take all of this, that is negative, and you're going to put it on this side. You're going to take this 180 squared and going to bring it over onto this side. That will be your first step. All right. So let me write that out for you. All right. Let's go step by step. So it will be 2 times the 150 times the 120, and the cosine of phi, theta phi, will be equal to, this remains on the right side, which is 150 squared plus 120 squared, and you're subtracting this value, which is 180 squared. And then you would divide by this. Take that and divide it under here. So because I don't have a lot of space, I'm just going to divide it. So I'm just going to move it from there and divide it under here, right? So I'm dividing by this, all of this right here. I'm going to just move it and I'm dividing it under here. Just to skip out a step. And then now my phi right here will be cos to the minus 1 of all of this thing, which I'm going to do again in one step. So I'm going to move this to the right, just because I do have a space. Let's move this equal here as well. And then the cos, I'm going to take cos to the minus 1. So I'm using the cos to the minus 1. I'm going to put the minus 1 on it of this entire thing. That is theta. All right, I hope you watch over about the video and you see the steps and you try and do it yourself. But I'm doing this way because I don't have a lot of space. And actually, when you practice enough, you can actually go from this line straight to this line. All right, when you practice. All right. So it's just a matter of plugging all of this in the calculator. Now you might ask, why didn't I work out this part first and work out this and work out that and then work out this? Because that is waste of time. You don't need to do it. When you're doing questions, you need to do it in a way that you use a calculator once. And I would use my calculator once right here. I could just plug that into my textbook display calculators. You need to get one of those and I will get the answer one time. All right, so let me bring up the calculator. I'm going to split the screen and bring up the calculator. Where are you, calculator? Here it is. All right, so I'm going to put this in the calculator now and see what that angle is. All right, so make sure the calculator is in degrees. First thing, so you have to the DEG up there on the calculator. I'm going to do cos to the minus 1, and in there I need a fraction, and it is 150 squared plus 120 squared, and I'm subtracting 180 squared, and I'm putting that over 2 bracket 150 close bracket, open bracket, 120 close bracket. And see, I get an angle of 82.8 degrees. 82.8 degrees. When your answer is not exact and they did not tell you the level of accuracy, you'll give your angles in degrees to 1 decimal place. And so that angle phi is equal to 82.8 degrees. That is the angle right there. Why do we go with that? Are you okay with that?
Yes, sir.
All right, so we now know this angle. I'm still going to just call it phi. All right, I now know this angle here. I'm still going to just leave it as phi on the diagram, but I know what it is, right? So now that I know this angle and I know the side opposite to it, Going forward, I can use sine rule. So if I want to find this angle down here, for example, I can use sine rule. This has one pair, and that has the other pair to find sine rule. Remember now, when using the sine rule and cosine rule, you know three things and you're trying to find a fourth thing. All right, you know three things and you're trying to find a fourth thing when using the sine rule and cosine rule. All right, but let's see what else they want us to calculate. The next thing they want, so the question ends on this sheet, but there's another document. So I have to remember that the angle here now is this. But let me bring up the next sheet on this side of the screen. Because what happens is that I have the file split in two different, I have the paper split in two different files. All right, so looking for part 2, which is right here. All right, so you see it starts back where this one just ended. So this question now is telling us that the bearing of P from L, the bearing of P from L is 210 degrees. So remember now, you always know the from position. Bearing of P from L. So it's from L to P. The bearing is 210 degrees. We need to show this 210 degrees on the diagram so that we can calculate what they want. They want us to calculate the bearing of M from L. So they want the bearing from L to M. You have to note the from position. All right, so let's put in this angle first that they gave us. So it's gonna help us in some way. Bearing from L to P is 210. So this is the from position. Sorry, this is the from position right now. Let's put it in red. This is the from position. It's from L to P down here. The bearing is 210. All right. So let's see how that would go. So it's like you're standing at the from position first, right? At the L. You're facing north. And then it is the angle through which you have to turn to the right in order to face the P down here. This angle that you turn to the right is the bearing angle. So that is the angle that is equal to 210 degrees. All of that is 210. Remember now, we know this angle inside here now. We know that the angle in here. Let's write it now. So since it becomes relevant, we know it is equal to 82.8 degrees. So the angle, the blue angle here is 82.8 degrees. Let me write it. So this angle is 82.8 degrees. All right, so we know that. The question is asking us for bearing from L to M, from L again to M. So we're talking now, let's do this one in purple now. We're talking now about the bearing from this point L again to this point M. So again, L is the from position, but this time you want the bearing to M. All right, so what would you do? Let's show it in purple now. So again, you would stand at the from position L and you would face north first. I'm doing the second bearing in purple. This is me facing north. That's the north direction. This would be the angle that I have to turn to the right in order to face M down here. So the bearing that they want is this one in purple, the purple one, which I'm going to call theta. So I'm saying the bearing from L to M over here, I'm going to say it is theta. I'm going to say is the bearing of L from M is the theta on my diagram, that purple theta angle. And since I know that the whole angle around here is 210, and the angle inside here, the piece inside there is 82.8, then it means that this purple angle is actually then equal to the whole red angle, which is 210 degrees, which was that bearing, minus the angle inside the triangle there, which is 82.8 degrees. That is what that bearing angle is equal to. All right, and I can actually show the calculation on my diagram like I did here, and it will be accepted. All right, it will be accepted. It was 210 yes. Wow, 210. What a coincidence. 210. I just opened my calculator and said 210 on it from another calculation. Unrelated. So it works out to be 127.2 degrees. But because it's bearings, it generally give it to 3 digits. And so I'm going to just write 127 degrees. So I'm going to write bearing of M from L is theta, which is 127 degrees. And my calculation is shown here on my diagram. If you want to show it here again, no problem. But that is it. But good at that? But okay with that?
Yes, sir.
Yes, sir.
All right. What else I want? It says no.
Yes, sir.
Calculate. All right, good. It says calculate the angle. Calculate the angle NLP now. All right. NLP. Where is that? Oh, so they're calling this point up here N, right? That's what they're talking about. Let's look at it. So they want us now to calculate this angle. Let me mark it in a different color. Green. NLP. So they're talking about the angle down here. So we're talking about this angle. They want us to tell them that angle first. And then they want the bearing of L from P now. So from P, look carefully. They want it from P. You have to always note the from position to L. From P to L. That's the bearing that they want. But they want us to use this angle. God said hence. So we have to calculate this angle first. NLP. Which, as I said, is the green angle that I'm drawing over here. N to L to P. This is the angle that I want. And that's kind of easy because remember now that this angle would complete a circle around this point. Total angle around that point is 360 degrees. So I'm going to leave this angle in green here and show the calculation. This angle right here. So that angle and the 210 would give you 360. And so this green angle that I want, let's point to it, is going to be equal to 360 degrees minus the 210 degrees. But you can appreciate that because the total angle around the point L is 360. And that red angle there is 210. So the remaining piece will be 360 minus 210. But you can agree with that? But good at that?
Yes, sir.
That's 110 degrees, 150 degrees. Then now it wants the bearing from L. See it here? From L to P. From P to L. So for this question now, my from position is P down here. This is my from position P. Let me do that bearing now in another color so I can show you. Let's do it in blue. The bearing from here up to there. That's the bearing that I want. So this is now my from position, and I want the bearing up to there. So remember, the bearing is measured at the from position. So let me take off this out the way. Let me take this out of the way. So it's like I'm standing at this from position now, right? Standing at this from position. I have to face north first. Remember, it is a clockwise angle from the north direction. Face north first. That's my north line at the from position. And it's the angle through which I have to turn to the right. I have to turn to the right in order to face L that I'm measuring the bearing to. So the angle that I want is this angle right here. That is the angle that I want. Let me call it alpha. Put back my north line here. Alpha. So I'm going to tell the examiner that the bearing of L from P up here, I'm going to say is the alpha in my diagram. It is the alpha in my diagram. So what you have here now, guys, is that these two angles are co-interior. Because if I complete this thing in blue for you, this north line and this north line and this line joining them at the base down here, they form out the U that we always talk about. It's like you have a U forming, see? Like it forms a U. Call it the U angles. Proper name for them are the co-interior angles. So this angle that I'm marking out in black, that means a different color. All right, that means a different color, yellow. These two angles that I'm marking out in yellow, the one that we just found, which is a 150, and the one that we want, which is the alpha, both of them are supplementary. They add up to 180 degrees. They are the co-interior angles because they are angles between these two parallel lines joined by this transversal line, or that line joining both of them. So like we form the co-interior angles, or we call them the U angles. So since the one up here is 150, it is obvious that the one inside here is 30 degrees. That's the angle, but I want the bearing. All right, so the bearing is 0, 30 degrees. All right, so we can say the angle over here, the bearing angle over here is equal to 180 degrees minus the 150 degrees, which is 30 degrees. But because it's bearings, you have to put the 0 in front of it because you must have 3 digits. And that is my angle right there, bearing angle from P to L, L from P. Are you good with that? Are you okay with that?
Yes, sir.
And then this
Yes,
angle,
sir.
remember,
Yes, sir.
this angle, remember, it came out to be 150 degrees on our diagram. All right, and it is there on the diagram. All right, so I like this question. This is a nice question. It ends right there. All right, that was a nice question. All right, so remember, I want you to go and redo all the examples that I'm doing. Very important. Go and redo them, and the sooner you redo them, the better. Don't wait until next week. Do it this evening when the information is fresh. And if necessary, use a video to help you, to remind you of what we did. All right, you have to be able to do these things by yourself. All right, so let's go and look now at another paper, 2022. Let's look at 2022. All right, I like that one a while ago. That one was very nice, very nice. I like it a lot. All right, 2022. Okay, let's see what this one says now. I mean, there's a bearings question on almost every paper, almost every paper in section 2. Get a bearings question because it is like the topic, the application topic for the use of the sine rule and cosine rule. See that? That's another paper, that's 2022. You see, it's another bearings question right here. All right, so let's go. And as you read information, you put it on the diagram. Anything that is not the diagram that they have stated in information, put it on the diagram. I tell you, the setting the questions easier these days because almost every time now, when they give a bearings question, they give you a diagram. In the past, you would have to draw the diagram from scratch. So it's much easier now. So this one says, from port L, ship R. So leaving from port L, and the ship is R. So you're not going to say R. Well, ship R, we'll have R right here. But anyway, it don't matter. It says, from port L, from a port L, ship R, oh, it's 2 ships. So this is a port, that is a ship. And apparently this is another ship. All right, good. So from port R, from port L, sorry, ship R is 250 kilometers. See here, 250 kilometers on a bearing of 060 degrees. So in other words, from L to R, the bearing is 060 degrees, 065 degrees. I'm going to have to show this bearing angle on the diagram, I'm sure. Let's put it on from now. So this is from position. We want the bearing out to R, out there. So you have to stand at the from position first, right here. And you face north, that's the north direction. It's the angle to which you have to turn to the right in order to face R. So that angle is this one. So that is the angle that is 065 degrees. So we can just mark it. This angle right here is 065 degrees. Let me write it on there. This is 065 degrees. That is the bearing that they just gave us. That is the bearing that they just gave us. All right. And then they're telling us that T now is 180 kilometers. See T down here? It is 180 kilometers from the same L. See, it's from the same L. It shows the distance here. But this time it's on a bearing of 148 degrees. So they're basically saying is that from here to here, the bearing is 148 degrees. Let's put that one in red now. So from here to down here, the bearing is 148 degrees. So this is the front position again, and the bearing is 148. So again, it's like a standard this front position. You face north first. This is the angle that you have to turn to the right in order to face the place that you're measuring the bearing to. This is the 148 degrees that I've marked out in red. I'm going to leave it there on the diagram. I'll extend my outline up here. That is 148 degrees. All right, I may make it a little smaller. This is 148 degrees right here. That I'm leaving in red. But can I agree with that?
Yes, sir.
But can I get that? All right, cool. It says this information is illustrated on the diagram below, except the angles, right? They give the distances, but they didn't give the angles. And also give the points, but they didn't give us the angles, right? So, we put the angles on the diagram. It says, okay, complete the diagram by inserting the value of angle RLT. All right, so I want us to insert angle RLT, which now is the angle between these two sides, R to L to T. Let's do the part in purple. So the one angle from R to L to T. That's the angle inside here. So clearly now, if the whole angle up here is 148, and this piece is 0.65, then the angle inside there between these two that they want is the difference between 148 and the 65. So we can show the calculation up here. 148 degrees minus 65 degrees. So even though we put 0.65 for the bearing, the angle is still just 65. And so that is what? Equal to 83 degrees. That's correct? That's correct? Somebody paying attention?
Yes, sir, that's correct.
All right, good. So this is 83 degrees. So you can show it down here now. See, that is 83 degrees. So I must put it on the diagram. So insert in the value of the angle. So we have placed it there on the diagram, right? Then it says now, calculate RT, the distance between the two ships. That's the only distance we don't know. We know this one, we know that one. The distance that we don't know is this one. So again, this is a typical case for the use of the cosine rule, because you know two sides and you also know the angle between them. So it's cosine rule that is going to help us to find this side. So let's set it up now. Cosine rule for RT. Cosine rule for RT. So we might start like Pythagoras' theorem. RT squared is equal to this side squared plus that side squared. That's 180 squared plus the 250 squared minus a piece. Remember, that's not a real hypotenuse. So you have to subtract a piece, right? So you subtract twice the product of the two sides, 180 and the 250. And you take the cosine of the angle between them, which is the 83 degrees. Instead of writing like this with a square on that, I want us to practice, but we don't bother put the square on this. So we move the square and put the square root over everything. I want us to practice to just write this as a first line, because you notice you don't have a lot of space to work. You don't have time to write another line, really. So you have to practice to just do the cosine rule and write it out like that and put the square root on this rather than put the square on that. And so you put this in the calculator and work it out, and the answer is in kilometers, right? Distances are in kilometers. Let's get the calculator and work it out. Over here. Okay, so calculator. And it says we are going to do square root of 180 squared plus 250 squared minus 2 bracket 180 close bracket open bracket 250 close bracket, and then the cosine of 83. That gives me 289.9. I'm going to give it 3 digits and just write 290. So I'm going to write 290 kilometers. That's what it corrects to. 289.7 corrects to 290 kilometers. All right, that is this side over here. I'm going to put it on the diagram. So this side is equal to 290 kilometers. Now that I know this side and the angle on the opposite angle, I know both of them, I can now use sine rule everywhere else. Now note, the only thing we don't know in this triangle now are these two angles. Those are the only things that we don't know now. We know the 3 sides and we know this angle. So sine rule can be used to find any one of those two angles now. And most time that is what's gonna happen. We're gonna have to use sine rule and use that angle for something. Let's see. They want the bearing now of T from R. Let's focus on the from position. Remember, you always have to focus on note from position. So going from R to T, the bearing must be measured at the from position. All right, let's write that better. It is from R to T. From position is R. So this R is where you're gonna put the north line and do the clockwise root angle stuff, right? So from R, let's look where R is on the diagram. So this is where R is. We're going down to here. So we want the bearing from R down to T down here. All right, let's look at it now. What angle that is. Put the angle on the diagram. Let me leave the calculator here. All right, so I'm gonna put the north line up here. This is I'm at R. I have to face north first, because I want a clockwise angle from the north direction. So like I face north first. That's my north line. And the angle to which I have to turn to the right until I am facing the T. That's the bearing of T from R, right? That's what I wanted, T from R. Right? Yes, T from R. So that angle that I've marked out here now is the angle that I want. And I always like to tell the students that the angle inside here most times will play a part in the calculations. All right, that angle most times will play a part in the calculations. Yes, and this time again, it looks like it will. Okay, look how it will play a part in the calculation now. So this line and this line, they are parallel. Let me go for the blue. Those are two north lines, right? This line and this line, two north lines. They are connected with this line down here. And so what we have is our U. We spoke about that U. And the angles in the base of the U are supplementary. So the angle here and the angle that we have over here already, which we know is 0.65, they add up to 180 degrees. Yeah, supplementary angles. Call them co-interior angles. All right, so it means then that this angle right here is actually equal to 180 degrees minus the 65. So it's 180 degrees minus the 65 degrees, which is equal to 180 minus 65 is how much that? 115. That's correct. Students, are you with me?
Yes, sir.
All right, so that's 115. Then now the angle that we want over here, the bearing angle that we want over here, let's call it theta, so we can make a reference to it, theta. And I deliberately put the angle alpha inside here because, as I said, most times when you want the bearing from a point, the angle inside the triangle at that point will play a part in the calculation. And so I normally mark it and see how it would play a part in the calculation. And what it is now is that we have a situation where we have total angle around the point is 360 degrees. And we want this part of it. We need this part of it, which can be used, which can be found using sine rule. And we now know this part of that 360 degrees. So that angle theta that we want right here, for to write as a formula to become equal to 360 degrees. Let me put it down here. It will be equal to 360 degrees minus this piece, which is 115. And also we'll have to subtract the alpha inside here. And to find the alpha, we have to use the sine rule. So this is going to give us our bearing angle, this, but we need to find the alpha with the sine rule. So let's copy this down and say it, right? Copy it down and put it here. So that's what we're doing down here. So the bearing of T from R, we're going to say is the theta, right? Is theta, which is equal to this. And we need to find the alpha. Let's find the alpha in red. So we're going to say, okay, we need the alpha. We need to use sine rule to find it. Sine rule for the alpha. We use sine rule for alpha, right? So I know is sine rule. Well, firstly, you never have to use cosine rule in the same triangle twice. Never. Right? Once you use cosine rule in a triangle, you never have to use it again. Because it creates a situation now where you know an angle and a side that are opposite to each other. And once you have that, you can use sine rule. So I'm using this angle and side opposite each other as one pair, and I'm using the alpha with this side over here as my second pair in the sine rule. And I know three things: 1, 2, 3, and I'm trying to use them to find that angle. All right, so I'm going to use the sine rule with those figures. So since I want to find the alpha, I'm going to start by writing sine of alpha over the side opposite. So I'm going to write it right here, and then we can copy it down. So I'm going to say sine of alpha over the side opposite to the alpha, which is 180 over 180, is equal to sine of the angle that we know. Angle that we know is 83 degrees, over the side opposite the 83 degrees is at 290. That's the sine of alpha, and that's the sine rule, you know. And then to make alpha the subject, what we would do is multiply the 180 up here first. And then after I multiply the 180 up there, we'll take the inverse sine. All right, let me go step by step and show you on the next page. So that's the sine rule. Sine will give us this, right? Copy this. I'm gonna paste it down here. Paste it right here. All right, and I'm just trying to find the alpha in this corner. I'm just trying to find the alpha first. Trying to make the circle smaller. All right. Because I want to use the alpha value that I have here. I want to use the alpha that I get. I want to use it back there. All right. So I'm going to multiply the 180 up here first. And I will get that sine of alpha will be equal to 180 times the sine of 83 degrees divided by the 290. Then to make alpha the subject, I have to take the inverse sign in front here, sine to the minus 1. And so the alpha would be sine to the minus 1 of everything here. 180 sine of 83 degrees over 290. Now I want us to get to a stage where we don't have to write this line. We have to practice in a way so we can go straight from this line to this line. All right, we have to practice that way. But in any case, we're going to put this in the calculator now and work it out, see what the alpha is. And we're going to use that alpha value back up here. Do the question the same way every time. Let's work out what the alpha is. So I'm back to the calculator now. So it's sine to the minus 1 of a fraction. And it is 180 times the sine of 83 divided by 290. And make sure the calculator is in degrees. I'm getting 38. Remember that's degrees, 38. All right, 38.0. So I'm going to write 38 degrees. And then that 38 degrees, I'm going to use it back here for the alpha. All right, so if I go back to my original calculation, which is the bearing angle calculation, then I say, therefore, the bearing angle theta on my diagram, all right, which is this bearing angle over here, right, reduces to 360 degrees minus 115 degrees and minus the alpha is 38 degrees. And that becomes my bearing angle. Let's write it out. 360 minus 115 minus 38. I'm getting 207. It's already 3 digits, so I can leave it like that. That is my answer right there. 207 degrees, question done. How was stay? How was stay? How we going? How we looking? But all right?
Yes,
Yes,
sir.
sir.
It's looking
All right.
good, sir.
Yes, sir.
Remember, I know. Somebody have a question? All right, no question about it. Good. Remember, I know, guys. It always looks super easy when I'm doing it and explaining it. You have to go now and prove that it is easy by doing it over by yourself. You have to redo the questions, do them over again, do them by yourself. Use the video to help you. All right, that's an advantage of having the videos. You use the video to help you. Back in the day when I was in school, there were no videos. When class done, it done. You have to go in the notes and try to figure out stuff. Now you have a video that can literally replay the class and replay the solution. So you have no business not learning this thing properly with all that tool, all that equipment, all that is available to you. Maximize the use of what is available to learn this thing the right and proper way and master it. All right, let's look at 2021. Let's look at 2021. See what is set in 2021. All right, we can have another short session tomorrow. We can practice some more, but I'll let you know. All right, hope everybody's here. I'm not having classes separate now. Everybody comes together because everything is online. Once the session is online, everybody can attend. So I don't have to repeat what I'm doing today, tomorrow for another group. It's not like we're having face-to-face. We have to repeat the same thing for the Sunday group and for the Monday group. Right now we can maximize and get more work done by everybody attending the sessions online. All right, so you all need to attend and encourage persons who are not attending to attend. All right, so let's look at this one now. What is there? See, it's another bearings question. So it's almost like, I mean, that's all they set, really. 99% of the time, they set a bearings question in section 2. All right, so let's look at this one now. All right, and see again, they're helping you. They're giving you a diagram, so it's much easier when they produce a diagram for you. All right, so this one says, from a harbor H, this is a harbor H. it says two ships, Q and R, are 069 degrees, that is Q, and they show the 069 degrees. So you see they're helping you, even show the angle there, and 150 degrees. So from H to R, the bearing is 151 degrees. That is from here to here is a 150 degrees, 151 degrees bearing that they did not show on the diagram. It also says Q is 175 kilometers from H. That's this distance, you know. And they did not show it. And it says R is 242, but they show this one, 242. So that's how they do sometimes. Give it the incomplete diagram and you have to complete it. See what I say here? Complete the diagram to show the information. I have to put on all the information, right? So first we're going to put on the bearing angle that they gave us that they didn't show, which is the 151 from here to here. So again, you are at the front position, you face north first, the angle is 151 degrees. It's the angle through which I have to turn to the right. This angle is 151 degrees. That angle is 151 degrees. All right, so let me just write that a little bit more. Get that like a smaller. All right, so let me just put it here. This angle is the bearing angle because it's the clockwise angle from the north line. Clockwise angle. That is a 151 degrees. And put it out here, 151 degrees. So if the whole thing is 151 and the piece up here is 69, then the angle inside here, which I'm going to mark in blue, angle between the two sides, which I'm going to mark in blue, this angle between the two sides, it becomes 151 minus 69. That's what it is, right? Angle in blue, 151 degrees minus 69 degrees to get the angle in blue. So sometimes I just write the calculation on the screen there, or on the page for them to see. 151 minus the 69, that's 82 degrees. So that angle is the angle inside here. It's 82 degrees. I write it 82 degrees. They also did not show this distance, which is actually 175 kilometers. I'm going to put it there. 175 kilometers this side. 175 kilometers. And so we have a situation now again where we have two sides and angle between them. And the only distance we don't know is this distance. And so that's it. That's what they might ask you to find, and we need cosine rule to find it because we have two sides and angle between. All right, so let's see. It says calculate the distance QR. Calculate QR, the distance between the two ships to the nearest kilometer. Nearest kilometer, this term, to the nearest kilometer means that you don't put it to any decimal places, right? You give it to the nearest whole number. That's what I mean. All right, I don't want no decimal, no point, nothing. So I have to use cosine rule, guys. Cosine rule. All right, cosine rule. So let's write it. Cosine rule. Cosine rule for QR. I'm gonna leave off the square this time. In fact, let me write it. Let me write it. So start like Pythagoras' theorem as usual. Start like Pythagoras' theorem. So it will be QR squared equals this side squared plus this side squared. Almost like it start like Pythagoras' theorem. 175 squared plus 242 squared. But it's not a right angle triangle, so you have to subtract a piece. So you subtract twice the 175 times the 242 times the cosine of the angle between them, which is the 82 degrees. All right. But again, instead of putting the square on this, I can leave off the square and put the square root over that, which is what I prefer actually. To leave off the square and put the square root over that. And so you eliminate a line. You eliminate a line. If you just write this by alone, it's good. And you put that in the calculator and you set it to the nearest kilometer. So don't put any decimal on it. All right, so let's get the calculator and work it out. So it's cosine rule again. I'm putting the square root of 175 squared plus 242 squared. Then I'm subtracting 2 times 175 times 242 times cosine of the 82. So actually, instead of putting the brackets, you can put times. I'm getting 278 to the nearest kilometer. The nearest whole number that is 278 kilometers is that distance QR. Anything else I usually want a bearing? It says, how far south? Aha, I like this one now. How far due south? Due south means towards the south. How far due south is ship R off harbor H? Now the word off also means from harbor H. How far south is it? Now let's look at what distance that is talking about. How far south? Let's put on the diagram. So it's R from H, right? All right, they want R from H because R of H is the same as R from H. So they want how far south is R from H. What distance are they talking about? Let me show you now. So remember, this is like on the Earth's surface, you know. Right? This is the north direction. You would have we across here, west to east, and you have south down here this way. All right. And I want to know how far south. So it's like the H is on this level, and the R is on this level. The distance south is this distance. That's how far south it is down here. That's how far south R is. If they wanted how far east, east is this direction, you know. So it would be now, if they wanted how far east, it's like you have this position here, and then the R is this distance to the right. That's how far east it would be. This distance that I have an R on will be how far east. If they wanted how far east R is from H, they will be talking about this distance. But how far south, as I said, is the distance down here. Distance down here. All right. So these are the grid lines now. The north-south line and the east-west lines. That's how they become relevant in these questions that we spoke about in class. So how do you know? Take this north line, right? It's a cardinal line, right? And you extend it down this way. And then from here now, your east-west line or your west-east line is this one. And so because this is an east-west line and that's a north-south line, and between them is 90 degrees. And so this becomes a right angle triangle that I've shaded. And remember now, the question is asking us for this distance, which I can call it, just call it X. So it's like it is X kilometers due south, or X is the distance due south. So we're trying to find this X over here. So we have to come and work in this right angle triangle. So because it's a right angle triangle, now we can use Sokar Tower, and we can use Pythagoras' theorem. So watch this now. If we can find, if this angle here will be very useful, then put it in purple. This angle right here, which we can find that angle right here. Why? Because the total angle along this line is 180, and this part of it is 151. So 180 minus 151 gives you the angle inside here. Let me mark it. So let's work it out on the calculator. 180 is the total angle on the straight line minus the 151. And that's what I want. That will be the angle inside here. All right. But I get that? But will that?
Yes, sir.
Yes, sir.
All right, good. So it will be 29 degrees. All right, let me just undo. So it will be 29 degrees inside that space, that angle right here. 29 degrees. And so now you're working in this triangle. You want the adjacent. This will be the adjacent. ADJ. because you know a right angle triangle, so you can go for so-called tower now. And the side over here that you know would be a hypotenuse. This would be a hypotenuse in this triangle right here. And so-called tower, adjacent and hypotenuse are connected with the cosine of an angle trig ratio. So-called tower. But you know which one to use based on what is involved. So what is it? We want the adjacent. We want the adjacent in that triangle. So I'm going to take the A's. A, so-called tower. And take this A as well, right? So the A in car and the A in tower. Taking them. I want the A, I want the adjacent, but I know the hypotenuse. The hypotenuse is involved because I know it. So I'm taking the H here and taking the H here. This one has 2 ticks on it. All right. Remember, to use the trig ratios, you must know 2 things to find a third thing. And so it is the car that we're going to use, which is cos. All right. So we'll set it up as a cos equals adjacent over hypotenuse. I can just work it right here now. I'm using the car. I'm going to set the cos of 29 degrees. Don't start this way. Don't start by saying x equals. Don't start it that way. Start with the definition, the trig ratio definition that you're using. All right, which is to say the cos of the 29 degrees is equal to the adjacent side, which is the x, over the hypotenuse, which is the 242. And you're going to take this 242 and multiply it up here to leave x as a subject. All right, so the x is going to be 242 cos of 29 degrees. I'm not writing so clearly, but you can make it out. So x is equal to this 242 times the cos of 49, cos of 29. And so the x works out to be, let's do it on the calculator, you know. So it's 242 times the cos of 29. That's 212. I'm going to go to the nearest kilometer again. They said it's here. Over here, what did they say? Oh, I'm going to use nearest kilometer again. Eh? So that's what it is. 212 kilometers. And then I just need to copy this down. Copy that down. Copy. And paste it down here. And that's my work. Right? So the distance that I want is 212 kilometers. That's how far south it is. If I want it how far east, which will be this distance, you just use sine because this will be the opposite. So you use sine equals opposite over hypotenuse instead. All right, if they wanted how far east. Well, that is it, guys. That is it. Everybody good with that? But okay? But I take that?
Yes.
Right.
Yes, sir.
It's already. I don't want to kill it. I don't want to give it too much. So I'm going to just do one more. Let's just do one more. And then I'll call it a day. So there are 4 questions to do. 4 questions. If you notice, they're really very similar. All right, so I'll look at the June 2019. We can practice some more tomorrow. All right, practice some more tomorrow. More maths equals better maths every time. So we have to practice a lot. All right, so let's look at 2019. What was it? 2019. All right, let's see. All right, so this one is not a bearings question, but clearly this triangle is not a right angle triangle, so we'd have to use sine rule or cosine rule in it. We know two angles, and so it's easy to find this one down here. Do I do this one or do I do another bearings question? Let me see. Looks fairly easy. We do this some other time. Let's find a bearings question. So let's look at 2018. Really want us to focus on the bearings. So let's look at 2018 and see if there's a bearings question on that one. All right. Let's see. Let's see. Where are you? Bum 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 bum. Bum 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 bum. Bum 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 bum. That's some nice, interesting. It's a bearings question again. Once I said an outline the diagram, I know it's a bearings question. So let's go. Let's see what this one says. This one says, the diagram below not drawn to scale shows the relative position of three reservoirs, B, F, and G, all on level ground. The distance BF is 32, that is shown here. That is shown right here. FG is 55, that is shown here. And the angle BFG 103 degrees is shown there. So everything that we have spoken about so far are shown. Then they tell us that the bearing of F from B, see? Bearing of, and F is on a bearing of 0.42 degrees from B. So from B to F, this is the bearing right here. All right, 0.42, and let's put 42 degrees on the diagram. All right. So everything that they have set up here is shown in the diagram. So the question is that much easier. Okay? I don't have to figure out any angle, right? So what do we have? Let's analyze. We have two sides and an angle between them. So cosine rule will help us to find this side. All right, so I know that for a fact. But first, it wants us to determine bearing of P from F. Let's look at it carefully, everything important. P from F to B, from F to B. All right, so what angle is that? From here down to there. Okay, let's look at it now. So again, you're gonna stand at the front position. Let's join the angle, join the bearing, sorry. Face north first. Face north first. It is an angle through which you have to turn to the right until you face B. That's the angle that I want. That angle that I've marked out here. That is the angle that I want. Now that angle, the only thing that is missing from around this point now is this angle that I'm going to draw in red. Or it is co-interior with this one. Because that's an outline. That's an outline. That's the line joining them there. And so we have this U. This is our U. And the angles in the base of our U are supplementary. They add up to 180 degrees. They are called co-interior angles. All right. Other times we could call them internal angles, but they are co-interior angles. All right. So since we know that, let me erase some of this. Since we know that this angle is 42 and they must add to 180, it means that this angle over here in red is 180 degrees minus the 42 degrees, which is equal to, what is that equal to? Minus 40 and minus 2, that's 138, right? 138 degrees. But it's really this angle we want, you know, the blue angle is the bearing angle we want. Let's work it out in red. So total angle around the point is 360. All right. And so this blue angle added to this 130 to make 360. And so the blue angle itself, which is the bearing, would be equal to 360 degrees minus the red angle over here, which is 138 degrees. All right, and that would give us the angle that we want. But good at that? Are you okay?
Yes, sir.
All right.
Yes, sir.
That's 222 degrees. So the bearing angle I want is 222, this answer right here. It is 360 minus 138, which is 222 degrees. From F to B. All right, from F to B. All right, there's some other ways that we can do it, but yeah, we work it that way for now. There's some other ways that it can be done actually. All right, I'll show you another way quick. Watch this. I'll show you another way quick and fast. More maths equals better maths. All right, let me show you something. All right, let's see if you can understand this. Watch this now. Let's do this another way for you. All right, let me take off. I'm leave everything. Watch this now. So you see this direction going this way? That direction is on a bearing of 42 degrees every time. This line. You've ever extend this line backwards like this. It's on a bearing of 42 degrees. So if I put an outline here, then this angle is 42 degrees. Right? So that line is a 42 degrees bearing line, this purple line. So because this is 42 degrees at this point, that purple line is also 42 degrees on this line. This direction is a 42 degrees bearing direction. So it means that right up here, look at it now, it means that right up here, remember I want to calculate that blue angle, that's the blue angle that I want. This part of the blue angle from here to here is 42 degrees. Because this purple line is on a bearing of 42 degrees. It's always 42 degrees to any north line. And then now, from here to here is 180 to 180. So to get the blue bearing angle, inside here, we could do the 42 degrees plus the 180 degrees. And that will still come out to the 222 degrees. That's another neat way we could have actually done it. All right, so you still get the same 222. All right, so there's not one way to do this thing, but I'm doing it this way for you to recognize that once you have the bearing on that line, it is that same bearing everywhere on that line, even if you extend the line. So the bearing is like a direction, all right, and the line is in that bearing direction. So everywhere on that line, the bearing is the same, 42 degrees, even at this point. All right, so that's just a nice other way we could have done it. All right, I think you understand that, guys. More maths equals better maths, More maths equals better maths. So, we have to do things different ways sometimes to fully understand. So I'm leaving both calculations there. All right, both of them. Okay, let's go another way. All right. So next question down here wants us to calculate the distance BG given the answer correct to 1 decimal place. All right, BG. Let's look at the diagram. BG is BG. So BG is this line that we don't know. This line. And now, what will help us, because we have these two sides, what will help us to find this side is if we can get the angle between here. Oh, we have it. Oh, wow, we have it. It's 103. Oh, so it's much easier than I thought. So we have the three things to use the cosine. We have the two sides and the angle between them. So this cosine rule is going to give us this side, BG. Can we just write it on it? Cosine rule. Let's just write it on it. Cosine rule. Cosine rule will give us this side. Cosine rule. Let's just write it on it. The BG is going to be the square root. I'm doing it now with the square root of this side squared plus this side squared. 32 squared plus 55 squared. But it's not an hypotenuse. You have to subtract a piece. So it's 2 times the 32 times the 55 times the cosine of the angle between them, which is the third 103 right there. Cosine of 103 degrees. Everything is under the square root sign. And this will tell us what the BG is, that calculation. Let's reduce and use the calculator on the screen. Let's do it right here. Where are you? Right, so it becomes the square root of 32 squared plus 55 squared minus 2 times 32 times 55 times the cos of 103 degrees. Are we getting 69.5? What is it? How much decimal place? It's a 1 decimal place. So it's 69.6 to 1 decimal place. 69.6. So this becomes 69.6 kilometers. So I can copy all of this down to the next page. Just paste it right here. Right there for 2 marks. And that is it. Then they want a bearing now. They want the bearing of G from B. Calculate the bearing of G from B. So remember, the focus is to note from position. So you want from B to G. So you're doing everything at the B. So I'm going to show it on the diagram. From B to G. Let's see if we can see what angle that is on the diagram. From B to G. All right, let me remove these now. All right, the only thing I'm going to leave is the length. 69. This is equal to 69.6 kilometers. All right, I now want the bearing from here down to there. All right, now what bearing is this line on? The line that takes it down there. So again, I have a standard from position. Let's zoom it up. Standard from position. And you have to, let's put it in red. You have to face north first. And then it is angle 2, which you have to turn to the right in order to face the G. Bearing of G from B. So that's this angle that I've just drawn. What I call theta, that red angle. As I always say, since you want the bearing at this point, the angle inside the triangle there will play a part in the calculation 99% of the time. So this angle inside here, which I'm calling alpha, will play a part in the calculation. So you can see that the theta that we want is the sum of 42 and alpha. So we can literally just write that. This bearing angle is equal to 42 degrees plus the alpha. And we're going to find alpha. We're going to work in this triangle here again. And we'll be able to use the sine rule now because we have an angle, a side and an angle that are opposite to each other, that we know both of them. So I'm going to be using for the sine rule to find the alpha. These two as a pair, and the alpha on this side over here as a pair. All right, so we need to find the alpha. All right, I'm going to do it on the screen right here because the diagram is in front of us. I'm going to do it right here and just copy it down, right? So the bearing that we want is theta, as we said. It is equal to 42 degrees plus alpha. And to find the alpha, again, we're going to use the sine rule. Sine rule. Right? And we're going to start with the sine of the angle over the side opposite. Sine of alpha over the side opposite, the alpha is a 55, equals sine of the angle that we know, which is a 103 over the side opposite, 69.9. So it's a sine of 103 degrees over 69, 9.9, 69.6. I want to make alpha the subject now. So I'm going to multiply the 55 up here. So they don't give a lot of space to work, guys. See, that's very small space to work. And we have to find alpha, and it's 1 mark. Let me see. I don't know why this question is just 1 mark. Let me see if there's an easier way to do it. Just 1 mark to do all of that. Because we calculate alpha with the sine rule. Let me see. Oh, no. Yeah, I have to do it. I'm not seeing another way right now to do it. The alpha. Yeah, because I don't have anything relating to this line down here. So I don't understand why it's 1 mark though. 1 mark looks a little bit for it, right? Oh, I'm doing the wrong angle. Down here we need it. Down here. Yeah, down here we need it. Sorry. Much marks right down here. Oh, 3 marks. Oh, better. 3 marks. Down here we do it. All right, not 1 mark. I'm just doing it here. And I'm going to copy it down because I want to do it where the diagram is, right? So the alpha becomes sine to the -1 of, I'm going to multiply 55 up here first. 55 times the sine of the 103 degrees divided by 69.6. And so this is going to give us the alpha. Let's do it on the calculator, all right? So it's sine to the -1 of a fraction, and it is 55 sine 103 divided by 69.6. And I'm getting 50.4 degrees. 50.4 degrees. Using this 50.4 degrees back up here. And so that angle theta becomes 42 degrees plus that 50.4 degrees. And so the theta becomes, if you add them, you get in 92.4 degrees. But as an answer in bearings, you're going to give it the 3 digits. You correct this to the nearest whole number, you're going to get 92. And you have to put the 0 in front of it because it's 3 digits you have to show. So it's 0.92 degrees. So that is the calculation. Let's copy it where it is supposed to go. It is supposed to go. Let's just copy that and put it down here. 3 marks, right? 3 marks. And that's where you're supposed to go. All right, that's it. Nice and easy. Any questions on that? Any questions? Question
No,
done.
sir.
All right, beautiful. All right, I'm gonna stop it there. I want to give you 2 minutes. So we did 2023, we did 2022, we did 2021. Skip over 20. There was none in 2020. Skip over 2019 because it was not a bearing. I would do 2018. 4 questions, guys. You can't tell me someone can't just do 4 questions. Redo this holiday and a break. Can't tell me you can't just redo these 4 questions for me. You have all these papers in the group, so search for them in the group and find the questions and do them. Watch over the video. Use the video to help you. Right, you need to master this topic. All right, and the aim is to have another session tomorrow. Everybody must come back. Then the Sunday class or the Monday class, everybody comes back tomorrow. That is the aim. If you have any changes, I'll send a message in the group. And also Christmas time and everything, and everybody busy. I'm busy as well. And so if for some reason I can't keep the session, I'll send a message and let you know. But my aim is to have a session tomorrow and also to have a session on Saturday. Saturday might be a little bit sticky. I can tell if I'm now, but I'll see. I just need a 1 hour, 2 hour window for us to have a class. All right, because I want us to be continuously practicing so we can master this thing. All right, guys, so that's it for today, and hopefully everybody will join us again online. Okay, bye everybody. Do what I tell you.
Have a good day.
Do what I tell you. All right then, cool.
Bye, sir.
All right, bye bye.